So we're going to look at simplifying square roots, adding, subtracting, multiplying, and dividing them. So we're going to go through that whole gamut of things today. So just a little reminders, that symbol is called a radical symbol. The number under the radical is called the radicand. And a radical symbol indicates only the positive square root of a number, called the principal root. To indicate both the positive and negative square roots of a number, we would use plus or minus sign. Perfect squares like 25, 36, okay, those are really nice. Anything that's not a perfect square, as we were talking about the other day, those are irrational numbers, and those we cannot simplify. We could find the numbers they lie between, but other than that, we can't do anything else with them. So example 1 says, estimate the square root of 27 to the nearest tenth. All right, now there's a really long, drawn-out manual way to do this by hand, but you have a piece of technology in front of you, and what does that piece of technology tell you the square root of 27 is to the 10th? And it better be between, what's it got to be between what two numbers? Between 5 and 6, okay? Square root of 25 and square root of 36. And so, Nolan, what do you get when you type square root of 27 in your calculator? 5.19. So if I'm going to write it to the nearest tenth, I would say 5.2, okay? Okay, and here's a little reminder of our properties of square roots. The product property. Okay. Now, even though we just did these, and it wasn't that long ago that we did these, we're doing them again because it's very important, because when we will be coming back to this, simplifying radicals quite a bit during the rest of this class and over the course of especially when we get to chapter 5, which seems a long ways away, but still we'll be hitting them then and once in a while between here and then. So, reminder of the product property. Okay. That if I have the square root of a times b, I can write that as the square root of a times the square root of b. Or if I have the square root of a times square root of b, I can write it as the square root of a times b. And we can do the same with the quotient property, that when we're dividing square roots. Okay. So you should have somewhere a list of the squares, right? All the perfect squares. We wrote them down before. So, is 32 a perfect square? No. Okay, so what's the largest one that goes into 32? 16, okay? So I can rewrite this as the square root of 16 times the square root of 2, and since the square root of 16 is 4, 4 times the square root of 2. Okay, so just a little quick review for us. Letter B, square root of 25 over 36. Natalie, what's that? 5, 6. Square root of 25 is 5. Square root of 36 is 6. So 5, 6. All right, simple review of it. Okay, a couple more here. All right, letter C, square root of 3 times square root of 12. This is an example of the product rule. So this means that I can do the square root of 3 times 12. Okay? Put them both under a single radical. And Alex, what's 3 times 12? 36. And the square root of 36 is 6. Okay. So there's the product rule. Letter D then would be an example of the quotient rule. I look at these two numbers I have here, 500 and 5. Does 5 go into 500? Okay, it does. Since it does, I want to write it as a single radical, 500 over 5, which simplifies to the square root of 100, which is 10. So a little review of the product property there and the quotient property. So whenever we have a fraction, we always want to look to see if we can simplify the fraction before we do anything else. Okay. Rationalizing the denominator. Remember, we said that you cannot have a radical in the denominator. So that means we want to get the radical out of the denominator however we can. Now, first of all, we're still going to look at the fraction and see if I can simplify the fraction first of all. So for letter A here, we have square root of 5 and square root of 2. Does 2 go into 5 evenly? No, it doesn't. Okay, so I can't simplify that fraction. So that means that I'm going to have to rationalize the denominator, and we put up here what to do again for that. That we're going to multiply both the numerator and the denominator by a number that produces a perfect square. So, if I have square root of 2 in the denominator, what do I multiply 2 by to get a perfect square? Multiply it by itself, right? Because 2 times 2 is 4. So I'm going to multiply the numerator and the denominator by the square root of 2. So in the numerator, we'll have 3 times the square root of 10. Since the 5 and the 2 are both under the radical, I can multiply them together. So then in the denominator, what's the square root of 2 times the square root of 2? 2. And that's my answer. Letter B. What do I do letter B then? First thing. A single fraction? Why, Alex? Okay, because we can simplify the 2 and the 8. So I'll write this as a single fraction of square root of 2 over 8. So which is the square root of 1/4. Is 1 a perfect square? Well, it is, right? Because 1 times 1 is 1. So 1 is a perfect square. Is 4 a perfect square? Yes. So the square root of 1/4 is 1/2. So, when we're adding and subtracting them then, letter A. So we start by looking at what's under the radical. Are these two things the same? They are. So that means then I can take the things on the outside, the 9 and the +7, and I can add them together. Because it's just like using the distributive property. I can do, they both have square root of 3, and then 9 plus 7. So this is 16 square roots of 3. Okay. Since we have the same thing under the radical, I can add them together. It would be just like I had 9x plus 7x is 16x. So I can add them. Okay, so letter B. 6 square roots of 5 minus the square root of 20. Are those things the same under the radical? No. Can I combine them? Not the way they are right now, right? Because they're not the same. Can I simplify the square root of 5? Can I simplify the square root of 20? Yes. Okay, so let's just focus on the square root of 20 for a moment. Okay. What's the largest square that goes into 20? 4. Okay. So this would be the square root of 4 times the square root of 5. And the square root of 4 is 2. So we have 2 square roots of 5 there. So I can rewrite this as 6 square roots of 5 minus 2 square roots of 5. Now, are these things the same under the radical? Okay, they are. So since they are, I can now combine the 6 and the -2, and I get positive 4 square roots of 5. So I can add and subtract if they have like radicals. If they don't have like radicals, I can't. But I want to look to see if I can simplify one of them so that they are the same. If I can, great. If not, then we go with it as it is.